Another known importance of dimension analysis is its ability to derive an equation between two quantities, right? So you can use dimension analysis to actually find relationship among quantities. Yeah, depending on information that is already provided to you. As usual, in this session, we are going to use examples and see how this particular way is also done as one importance of dimension analysis. So in the first example, which is usually fetched from our Atake, right? If you want to follow up, you need to have that book. That's the book that we use in most of our sessions, and there are a lot of examples inside. I promise you, there's a lot of examples inside. But then other books are there that are also good. But this is what we use to follow up the session. And then it's a book that has helped us in order to grasp a lot of concepts. And if you have it, then you can follow up because you will not be able to solve all the questions here. To try more hands on them, you need to get the book for yourself and then be solving them. Yeah. So in this session, we'll be focusing on this particular example to see how dimension analysis can be used to find a relationship here. So let's read the question together. The period t of a simple pendulum depends on the length L and the acceleration due to gravity g. Establish an equation between L, and g, right? So the period t. So let's write what is the question is. Let's translate that mathematically. They are saying that the period t. Let me get my pen for you. I think, yeah. So I'm coming in a second. So yeah. So they say the period t depends on is depending on length L and the acceleration g. Yes. So and notice that when they say and, we'll learn that later in mathematics. In mathematics, when you say and, right, you are basically doing multiplication. So L and G, right, depends on the length L and G. So L times G, probably that's what we have currently, right? So now this is the expression that we are getting. So they say the period T depends on L and G, and they told us what T is. It's a period. The L is a length, and then G is acceleration due to gravity. So it's basically acceleration. So you know all these quantities, but then you need to know how they are related, right? You know, right now we just have that depends on them, so L times G. But then how they actually come up, how does it depend on it? Is one squared? Is there one that is squared? Does one have to be below? Is L over do you have L over G? How are they actually related? You need to actually flesh it out and get the full structure of that expression. So just knowing this particular thing. So there are no values here, there's no number given to you here, but then you have to come up with that particular expression that fully defines everything for you. So we are going to use this onto the next slide, right? So let's be here. Let me say we had T proportional to LG. So this thing means proportional. So it depends on, when they say depends on or is proportional to, this is the symbol that we use, right? But then we don't want this. So to do that, we need to remove the proportionality. So in order to remove, whenever you are removing the proportionality, it is done by introducing a constant. We want to change this one to equals to. We don't want to use the proportion sign. So you need to actually do that first. So you have to introduce the constant of proportionality. Okay, so let's call it k. That constant is going to be k. So now if I'm introducing that, see how we do it. T is equal to k multiplying LG, right? So now, but we are not done. Before, if you are removing the coefficient, right, the k and then the L and G, right, what you have to do is that you have to introduce the powers, some powers x, let's say x and y here. There are going to be some indices that will be there too at the top. So when you're introducing the concept of proportionality, remember to make sure that all the variables here, not the t, not the one that is on the other side, the one that is depending on the rest, but then you need to actually focus on the variable that you had, the L and G that we have originally. You need to give them the x and y, or you can t and s. Make sure that they have given a power that's a variable that you don't actually know, right? Okay, so now this is the full flesh, the basic flesh of what we have. So from here we can build on, because we now have an equal to sign, right? So now what we do is that we want to take dimension of both sides too. So we take dimension of both sides, dimension on both sides. So we are taking the dimension of both sides. It means that the t we have here is a period, right? Is equal to the constant k, right, times the l, which is the length, right, to the power x, times g, which is acceleration, to the power y. Okay, let me get to the next line. So t is period, and period is time, so it's going to be capital T. The dimension is capital T. The dimension of a constant we said is 1. K is a constant. That's what we said. Constant of proportion, so it's a constant, so it's 1. L is what? Length of the distance from the previous, from the question, right? So it's length, so it's capital L. Acceleration is what? Lt to the power negative 2, because it's acceleration to gravity 2. So yes, so L is to the power x, right? And then g is to the power y. So we are just in the dimension, we maintain that. So next line we have 1 times L, 1 times L to the power x. That's from this one. Then, but then this particular y, you multiply this because of the brackets, right? You use indices. It becomes L to the power y, t to the power negative 2y. This is what we get at the end of the day by breaking down this. When you do this, what do we have? We have t is equal to L to the power x plus y, right? T to the power negative 2y. This is what we have at the end of the day. So if you see that, you can see that we now have to compare both sides. We need to find the value of s, y, x and y and all that. Now the t here has the power 1. Are you okay? So you have the power 1, but then we need to compare that t to the power 1 and there's t on the other side. So let's compare their powers. So we are going to see that negative 2y, right, is going to be equal to um negative 2y is going to be equal to um 1, because we are taking this one and comparing, because both t and t are the same on the both sides. So equal to sign is here. On this side, we have t to the power 1. On this side, we have t to the power negative 2y. So you need to compare their power indices because their bases are the same. So negative 2y is equal to 1. Then y is equal to negative half. Yes. Now, let's look at the L. So you see that the L, there's no particular component of L on the other side. So we finally got the value of y, right? We got the value of y, but now we need to find the value of x. So now, how do we sort that out? How do we sort that out? How do we sort that out? Let's think. So on the other side of this equation, when focusing on L, you see that there's no L component here. But then it is there, but it doesn't show. How is it there? It's just written as L to the power 0. Remember, anything to the power 0 is 1, right? So 1 times t to the power 1 is always there. If in fact there are multiple, there's even m here to the power 0, but then they don't appear in the equation because anything to the power 0 is 1. But in this case, because we need to compare L powers, right? We need to bring the L to the power 0 here. So it's like S to the power 0. So if you're considering this now, this to this, you now see that the powers are 0 and s plus y. So you can compare x plus y is equal to 0. At the end of the day, x is equal to negative y. But we got y already, and y is negative half. So if y is negative half, then we have x is equal to negative into brackets negative half, because y is negative half. So then x is equal to half. So at the end of the day, if you come back to this particular equation, right, we got x and y now. So then we rewrite the equation and say t is equal to k. L is what? L to the power x is power half, and g to the power what? Negative half. So if you want to rewrite this thing beautifully, you simply put it back like this. um T is equal to K square root of L over G. As simple as that. This is what we have for this particular expression. So we now see the full flesh of that the proportionality has been changed, and then it helps us to actually have the final structure or the actual relationship, right, between the quantities. Yeah, this is just example one. Now let's look at